In this video, I'm going to teach you real quickly about what a radian is and how to work with them. So radians is another way of measuring the size of angles. Just like you can measure length in inches or centimeters, you can measure how far open an angle is in either degrees or in radians. So let me explain to you real quickly what a radian is. Okay, so say that you have a circle like this. If this is the center of the circle, and these lines represent my radius, let's say that this arc length right here is also the length of the radius. So this is the length of the radius, this is the radius, and this is the radius. How far this angle has to open in order for this arc length to be the length of the radius is called 1 radian. And there are 2 pi radians that fit in one circle, which means that 2 pi radians is equivalent to 360 degrees because 360 degrees fit in one circle. And you might be interested to know that if you took the radius and you were measuring how many times your radius could fit around your circle, kind of like this. If I kept going and was measuring it perfectly, let's see, 1, 2, 3, 4, 5, it would look kind of like this. So you would say, well, 1, 2, 3, 4, 5, 6, plus a little bit, radiuses fit around a circle, which, by the way, is why circumference equals 2 pi r, because this 6 and a little bit is that 6.28 radiuses fit around the circumference of the circle. So, or 6.28 is 2 pi, so 2 pi radiuses make the circumference, which is then why 2 pi radians also fit in this circle, because each one of these wedges would have a central angle that's 1 radian. And then this would just be part of a radian. So we use that in order to convert from radians to degrees, because we can simplify this a little bit and say that pi radians equals 180 degrees. So if you look at your notes, when we are doing conversions, we always want to multiply by something equivalent to 1. So if we're starting with degrees, I'm going to multiply by pi over 180. So pi over 180 degrees is equivalent to 1 because pi radians and 180 degrees is both the same amount of a circle. So they would divide to 1. I put the degrees on the bottom so that I would have a degree in the numerator and a degree in the denominator that would cancel, so my unit that I'm left with is radians. So then when you multiply fractions, you multiply across the top and you multiply across the bottom. Now when we're working with radians, we're always going to leave it in terms of pi and leave it as a reduced fraction. So you can go ahead and simplify and do 45 divided by 180, which would be 1/4 pi, or pi over 4. Pi over 4 radians. And I don't have to write the word radians there. It's understood that since the pi is there and it's describing an angle, that I'm writing in radians. So if we do the same thing again, I'm going to multiply by pi over 180 degrees. Since I have a degree on the top and the bottom, they cancel, and I'm left with my unit of radians. For fractions, I multiply across the top, so 125 pi, and multiply across the bottom, 180. So now I'm going to simplify this fraction, which means I'm going to type into my calculator 125 divided by 180. Now when I do that, it's going to give me a decimal, but I need it back in a fraction. So in case you don't know the nifty shortcut on your calculator, you can click on the math button, which is the third button down on the left underneath the green one, and then you click enter twice. And it will convert your previous decimal into a fraction. So 125 divided by 180, math enter, enter, gives me 25 pi over 36 radians is equivalent to 125 degrees. So when we switch directions and convert from radians to degrees, I'm still multiplying by something equivalent to 1, so pi over 180. Whoopsies, sorry, wrong direction. That was before. 180 over pi. Now pi this time is on the bottom because I want my pi's to cancel so that I'm left with degrees. And now same thing. So fractions we multiply across the top. So 5 times 180 is 900. Multiply across the bottom and I get 3. So 300 degrees. I'll do this one more time. So 3 pi over 4 radians, I'm going to multiply by 180 over pi. Since I have 1 pi in the numerator, 1 in the denominator, they divide to 1 and cancel. Now I can multiply across the top, so 3 times 180 and get 540. Multiply across the bottom, I just get 4. So 540 divided by 4 is 135 degrees. Make sure you're including your degree symbol there. I did get one question in class today that I wanted to address. Some people were asking, well, when you're doing this, why are you multiplying across the top and across the bottom? Why are you not cross multiplying? And the answer is you only want to cross multiply when you have an equal sign here. If you're just multiplying fractions, you're going to multiply across the top and then multiply across the bottom. Okay, so let's put this all in context. So we're going to go back to arc length and sector area, but instead of just working with degrees, we're going to work with radians. A quick review though, before our arc length proportion was arc length over total circumference, that's the 2 pi r, equals x over 360. And our x would represent the degrees or the central angle of the arc that you're intercepting. If you preferred to work with it in an equation format, this is what it looked like. Your arc length is what fraction of your total circumference. So since today we've been talking about how there are 2 pi radians in a circle, essentially what you can do is you can take out this x over 360 and replace it with x over 2 pi, where this time the x represents how many radians you have. And you could do the same thing here. So instead of x over 360, it would be like x over 2 pi, where the x is representing, again, how many radians you have. So I'm going to show you one example problem of how to do it this way, changing out the x over 360 to the 2 pi situation. And then I'll describe a different way of solving it, and then you can decide which way that you prefer. All right, so for this one, what is the radius, that's what we're solving for, of the circle shown if the length of the arc, so that's part of the circumference, is 20 pi over 3, and the measure of angle y is pi over 3. By the way, since there's the pi there, that means it's talking about radians. So our central angle here is pi over 3 radians. Okay, so I'm going to use the equation. So the equation says arc length equals radians, or x, over 2 pi times 2 pi r, because that's my circumference formula. So we can plug in what we know. So arc length is 20 pi over 3. I know my x is pi over 3 radians over 2 pi, and then times 2 pi r. Now, one thing that you might notice is 2 pi r, that's the same as times 2 pi r over 1, which means that I have this 2 pi in the denominator and this 2 pi in the numerator, which means they divide to 1 and they cancel. So what I'm left with is 20 pi over 3 equals pi over 3 times r. So now I can multiply by 3 on both sides, which leaves me with 20 pi equals pi times r. If I divide by pi on both sides, my pi's divide to 1, so they cancel, so I'm left with my radius being 20 inches. All right, so a different way that you could solve it. If solving with these fractions and with, these 2 pi down there and canceling the 2 pi's like that, if all that stuff feels uncomfortable to you, here is a different way that you could go about solving it. Because we know how to convert from radians to degrees, you can do that first and then you can solve for the radius and you should get the same answer. So again, if our generic formula is arc length equals x over, I'm going to do 360 this time because I'll convert to degrees first, times 2 pi r because that's the circumference formula. So first, pi over 3 radians, if I convert to degrees, I'm going to multiply by 180 over pi. Pi's are on the bottom, so it cancels out. So I get 180 degrees over 3, which leaves me with 60 degrees. So now I can plug in 60 where x is. So arc length, 20 pi over 3, equals 60 over 360 times 2 pi r. I'm just going to go ahead and simplify on the right side of my equation first and get 20 pi over 3 equals, this would be 1/6, so 2 pi r over 6. You have a couple of options of how you could solve from here. I like to cross multiply. So if I cross multiply this way, 2 times 3 is 6, so 6 pi r equals, other direction, 6 times 20 is 120 pi. I'll divide by 6 pi on both sides. The pi's cancel. 120 divided by 6 is 20. So my radius is 20 inches. So you have multiple different ways of solving for these. One other thing that I just wanted to point out is here on the last one on number 4, it's switching from what is arc length or giving you the arc length to area of a sector. And just as a reminder, the formula that we used previously for the area of a sector was that area of a sector equals x over 360 times pi r squared. So your area equals a fraction of the total area. So the way that you'd swap it out for radians would be that your area of the sector would be radians over 2 pi times pi r squared. So again, if you are solving one of these problems and you're using this new method, then all you have to do is when you get stuck, just start over and first convert your radians to degrees, and then you solve normally with degrees.